Okay, let's keep on working on this solving rational equations. Our next step is going to be to try to work through one where our denominators are not as clean to begin with. So your first kind of initial reaction to this problem might be that, oh, okay, well, I'm going to multiply these two fractions, because they have a denominator of k, by k squared minus 3k. And then I'm going to multiply this fraction by k. While that will give you a common denominator, it's not going to give you the least common denominator. And I will tell you that you have a much better chance of solving this if you actually use the least common denominator. So to find the least common denominator, we're actually going to take a second and factor all of the denominators when possible. So that means that our first fraction, we can actually factor the denominator, because the denominator has a greatest common factor of k. So we can factor that greatest common factor out, and we get this fraction equals, and then the rest of them, we can't really do anything with k. So I'm just going to leave it. Now, on that right-hand side of the equation, you may notice something that could be helpful. On the right-hand side of the equation, we actually have the same denominator already. So we could go ahead and add those two fractions together now, and that might make things a little bit easier. You absolutely don't have to, because it will happen later in the problem, but you can. So let's say we wanted to do that. All right, so let me erase what I just wrote there. And I noticed in the beginning of this problem that the two fractions here have the same denominator. So I'm going to go ahead and add them together. When I add two fractions together, I use whatever that common denominator is for the sum denominator, and then I just add the numerators together. So I have 3 plus 2, that's going to be 5, plus k. All right. Now, I'm going to finish solving this. Now, some of you might look at this and say, oh, it's a proportion. I could cross multiply. Yeah, you could. However, that's going to probably get a little messy. You may end up with a cubic in your equation at that point, which can make things a little bit tricky. So I'm still going to go ahead and follow the steps that we talked about in the previous two examples, where I'm going to try to make all my fractions have the same denominator. So to do that, I'm going to have to multiply this second fraction by the k minus 3. So let me start by putting what was already in that second fraction's numerator in parentheses, because it's two terms. So I want to keep those two terms together as long as I can. So then I'm going to multiply by k minus 3 over k minus 3, because remember, when we're getting common denominators, we want to multiply by a giant 1. Okay, let's see what that gives us. So now I have 5k plus 3 over k times k minus 3 equals, now you could do one of two things here. You can just write it as 5 plus k times k minus 3, or if you're recognizing already that really what we're going to be doing here is multiplying a binomial times a binomial, you could go ahead and multiply that out. And I'm going to do that. So I'm going to take 5 times k, which is 5k, and then 5 times negative 3, which is negative 15. There's lots of ways you can do this. I'm just kind of showing you how you're going to multiply them all out. K times k, which is k squared, and k times negative 3, which is negative 3k. So I've gone ahead and multiplied that all out just to kind of give myself one less step to write. Now I recognize that my fractions have the same denominators. So I'm going to put this in parentheses again. Like I said, anytime I have more than one term in the numerator, I'm going to go ahead and put in parentheses. And we're going to follow the same process that we did in the previous video. So I'm going to multiply both fractions by k times k minus 3 over 1. I might run out of room here. K times k minus 3 over 1. And then once again, what's really nice, and this is why we do this, we end up with our giant 1s. This entire denominator and this entire numerator is going to give us a giant 1. Same thing here. This denominator and this numerator is going to give us a giant 1. And that eliminates all fractions from our problem. So now I just have 5k plus 3 equals 5k minus 15 plus k squared minus 3k. And at this point, it's a matter of grouping up your like terms and finishing that problem. If we group all the like terms together, you're going to get a quadratic, and you're going to have to solve that probably with factoring or the quadratic formula. So I'm going to have you pause the video here and try it on your own and see what you get. All right, so hopefully you were able to figure out that your two values for k are 6 and negative 3. Now here's where rational functions become a little tricky. So you have to actually make sure that these will work. 6, if I plug in 6 in this first fraction, in the denominator, I'm only looking at my denominators because I want to make sure I don't get zeros anywhere. So look, 6 and 6 are fine. Negative 3 and negative 3 are fine in the two fractions on the right-hand side of the equation. Where it could become a problem is right here. So if I plug in 6 here, if I plug in 6, let's see, I will get 6 squared minus 3 times 6, and that's 36 minus 18. That is not 0, so we are okay. So now let's go ahead and check the negative 3. So I will plug in negative 3 squared minus 3 times negative 3. That's going to be 9. And then again, negative 3 times negative 3 is positive 3. That's 18, which is also not 0, so that's okay as well. If at any point you get something that results in a 0 that's going to be in the denominator of your fraction, that means that the actual solution does not work, and you'll have to try something else. Okay, I'm going to give you a problem to try on your own on the next slide, and then pause the video, come back and try it and see how you did. Okay, so remember, before you try to do anything, you need to make sure that you have factored all of your denominators. So factor the denominators, then get your common denominator, and then go from there. Okay, pause the video, try it, and come back and check your answer. So this is my work, again, kind of talking you through it. I factored everything first, so I found out that this trinomial factors to be p plus 3 times p plus 3. And that led me to realize that this first fraction needed another factor of p plus 3. So I multiply by p plus 3 over p plus 3 to get a giant 1, so I don't change the value of that specific fraction. Once I've done that, I realized that my common denominator in my entire equation was p plus 3 times p plus 3. You may have written that as p plus 3 squared. That's fine. Now I know from there I can multiply by p plus 3 times p plus 3 over 1, and I do that for every fraction, and I eliminate all of my fractions. Okay, so what I'm left with is just p plus 3 minus 1 equals 5, and I can solve that very easily. I'm showing my check over here as well because it's really important to do so. Okay, that's it for this lesson. Let us know if you have any questions in Classroom or in the Google Meet, depending on where you are at the moment, and I will talk to you guys soon.